All right, we're going to start on Unit 7, Day 3. This is on combinations. So yesterday we talked about permutations. And remember, permutations is ordering something, and with permutations, order matters. So like first, second, and third place, or like president, vice president, secretary, things like that. The difference with a permutation and a combination is the arrangement of items in which the order does not matter. So like, for example, if I seat Sally, Bob, and Joe together, it doesn't matter that I write them as Sally, Bob, Joe, or if I do it Joe, Sally, Bob. Okay? They still have the same people. They're still all sitting together, but they're in a different order. So it does not matter because I still have those three people together. And so that adds a difference to our equation. So it's basically the same equation n factorial over, it's got that n minus r factorial, except for it also has a times r factorial. And still remember, n is the amount of people that you're choosing from, r is the amount that you're choosing. So like if I have three people and I only want to choose one, 3 would be my n value, r would be 1. Okay? So for example, we have 5 combination of 3. Okay? And so we would write that as 5 factorial divided by 3 factorial times 5 minus 3 factorial. Okay? And then we would simplify that, so that would become 5 factorial over 3 factorial times 2 factorial, because 5 minus 3 is 2. All right, and so say we want to start solving it. Okay, I can expand this top. That becomes 5 times 4 times 3. And notice I have 3 factorial on the bottom, so I can stop there because those 3 factorials are going to cancel out. All right, so that becomes 5 times 4 over 2 times 1, because 2 factorial is just 2 times 1. 5 times 4 is 20. Divided by 2 is 10. So that means that you can have 10 different combinations there. Okay? So then, say for example, we have 8, choose 3. I'm going to show my work down here just because there's not a lot of space there. So for letter, I'm going to label these as A, B, C, and D. All right, so for A, we have 8, choose 3, or 8 combination 3. So that would be 8 factorial over 3 factorial times 8 minus 3 factorial. And that becomes 8 factorial over 3 factorial times 5 factorial. And so you could continue to solve like I did up here, or remember I showed you how to type that in the calculator yesterday, where you do 8, go over to math, and then slide over, hit the right arrow button until you get to probability, and go down to option 4 where you've got that factorial. Divided by, and because I have 2 different things on the bottom, you do parentheses, 3 factorial times 5 factorial. And close your parentheses, and that gives you 56 different combinations there. Okay? And another way to do this, I'll show you with letter B, where we have 10 combination 6, is there's a combination option. Just like yesterday when we had a permutation option in our calculator, you can do 10, math, go over to probability, and look, there's an NCR option. So you hit that option and hit 6. And so that gives me 210. So without having to do any other work or writing out the equation, it automatically gives that to you. And so like I've said before, if you've got a calculator, go for it, use the calculator trick. If not, then you're going to have to go along and do the math way. And it's not that too difficult. So I'm just going to do a couple of them again. So with letter C, we've got 7 combination 2. Okay, so that becomes 7 factorial over 2 factorial times 7 minus 2 factorial. And again, to show you the mathematical way, that would be 7 factorial over 2 factorial times 5 factorial. And to write all that out, that would become 7 times 6 times 5. We see the 5 on the bottom, so I'm going to stop at 5 factorial over 2 factorial times 5 factorial, because those 5s are going to cancel out. So that gives me 7 times 6 over, and 2 factorial is just 2 times 1. So 7 times 6 divided by 2 gives me 21. Okay, so that's the whole mathematical way that you can do it. Or you can, again, just type into your calculator. So letter D. Now letter D, notice, is written as 14 over 5 in parentheses. Oop, I did not mean to put the bar there. 14 over 5 in parentheses. That's the same thing. It's just another way to write it for combination. So that's the same thing as saying 14 combination 5. Okay? And so, again, you can just do 14 factorial over 5 factorial times 14 minus 5 factorial. You can simplify 14 factorial over 5 factorial times 14 minus 5 is 9 factorial. And you can type that into the calculator. Just make sure you put everything that's in the bottom in parentheses. So that would become 14. Hit math, go over to probability, PRB, go down to the factorial, divided by parentheses, 5 factorial times 9. Hit math again, go down to factorial, close your parentheses, and that gives you 2,002 options. Or you can again hit 14, math, go to combination, and hit 5, because we're trying to choose 5, and again you'll get 2002. So either way is you've got 3 different ways to do it: the fully mathematical way, or you can do it the calculator way, typing in the factorial, or just the in choose R or in combination R option. Okay, so here's some examples with some word problems. We have 12 boys and 14 girls. And Miss Schultzke's, I guess that's how you say it, math class. Find the number of ways that Miss Schultzke can select a team of 3 students from the class to work on a group. The team is to consist of 1 girl and 2 boys. So sometimes this can try to trick you up because you're like, oh, well, you need 3 students. Yes, we need 3 students, but they specifically have to have 1 girl and 2 boys. So that means we're going to have 2 different combinations here. We have first the girl option, where you have 14 girls total. So we have 14, and we need to choose 1 of them. So we need to find out how many combinations of that is. And we have our boys, so that's 12 boys, because we have 12 total, combination 2. And remember, I talked about with permutations, you do the same thing with combinations. Whatever answers you get between those 2, you multiply them together. Okay? And I'm going to do the shortcut way just because of space on my paper. So I'm going to do 14, math, combination 1. So we have 14, choose 1, so that's 14 options for my girls. And then if I want to choose 2 boys out of 12, that's 66 different combinations of those boys. So 14 times 66 gives me 924 different ways to combine groups of 1 girl and 2 boys. Okay? So let's look at the next option. We have a basketball team that consists of 2 centers, 5 forwards, and 4 guards. In how many ways can the coach start doing a starting lineup of 1 center, 2 forwards, and 2 guards? So this time we have 3 different combinations we need to figure out. We only want 1 center, but we have 2 of them. So that's 2 total centers, and we want to choose 1 of them. We have 5 forwards, and we want to choose 2 of them. And then we have 4 guards, and we want to choose 2 of those. Okay? So that means we're going to have 3 different things here, and we're going to multiply all 3 of those numbers together. So we have 2 math. We want to choose 1, and that's going to be 2 combinations there. We have 5 forwards, and we want to choose 2 of them. Oops, I hit the wrong option. There we go. And that's 10. And then we have 4 guards, and we want to choose 2 of them. So that gives me 6. So 2 times 10 times 6. And that's going to give me 120 different combinations of players that I can use for my starting lineup. And notice why this is important, that these are combinations and not permutations. With combinations, it doesn't matter which 2 boys, if I use Bob and Joe first or if I do Joe and Bob. They're still in the group of 3 no matter what. So it doesn't matter what order I put them in, they're still going to be in a group regardless. Same thing with the basketball. It doesn't matter which two of the forwards I say that I'm choosing, they're still going to play. It doesn't matter if I say that Alex and Cameron are playing in the basketball game first, they're both playing, so it doesn't matter. So that's why the order does not matter. Okay, versus a permutation, it matters whether I say Cameron or Joe or Alex and Bob or whatever. Okay, so let's look at letter 3, or number 3, I mean. There are 14 juniors and 23 seniors in the service club. The club is to send 4 representatives to the state conference. Again, this is a combination because it doesn't matter how I order those 4. They're still going to the conference regardless. It doesn't matter if I say person A, B, C, and D, or if I say person D, C, B, A. They're all still going. I just said them in a different order. So order does not matter here. All right, so we have 2 different scenarios here. We say how many different ways are there to select 4 students to attend the conference. So notice in this situation, it doesn't matter whether they're a junior or a senior. We just want to choose 4 of them. Okay, well, I have 14 juniors and I have 23 seniors. So we're going to add those 2 together, which gives me a total of 37. Okay, so I have 37 total and I want to choose 4 of them. So when it doesn't matter what they are, whether they're senior, junior, freshman, sophomore, whatever, we are using the total of them. So 37, math, go over to our combination again. And we want to choose 4 of them. So that means I have 66,045 different combinations that I could use. Okay. And then letter B, it says if the members in the club decide to send 2 juniors and 2 seniors, how many different groupings are possible? This is when it matters whether we're talking about juniors or seniors. So we have 2 juniors that we want to choose, and there's 14 total. So that's 14, choose 2. And then with our seniors, we have 23, choose 2. And whatever we get, we multiply those together. So we have 14, choose 2. That gives me 91. And then 23, choose 2, and that gives me 253. So I'm going to multiply those together, and that gives me 23,023 different combinations of seniors and juniors that can go. Okay? All right, I'm going to flip over to the next page. The last thing we're going to talk about in the notes is the difference between combinations and permutations, and reading these options and saying, okay, is it a combination or a permutation? Remember, permutation means order matters, versus combination, order does not matter. Okay, so like for example, picking 3 team members from a group. Okay, don't think so like a lot of people try to overthink these problems, whether it's a permutation or combination. Doesn't matter how I say Billy, Bob, Joe, and Alex are on the team. No, if I say Alex, Bill, and Joe, it doesn't matter. All 3 of them are still on the team. Doesn't matter how I say that they're on the team, they're still there. So this is a combination because it does not matter how I order those 3 team members that are on the team. Okay? Then the next one says picking a team captain, pitcher, and shortstop from a group. Now notice, if I say that Bob is team captain and Alex is pitcher, and then all of a sudden I switch it up, that means they have 2 different roles. That is why when order matters, because it gives them 2 separate roles if I switch them up. So this is a permutation. Okay, so combination and permutation. The next says picking first, second, and third place winners. Now, again, does it matter whether you're first or third? Well, yeah, you're going to feel a lot better if you're first instead of third place. So, yeah, order matters as to which one you place in. So this, again, is a permutation because it matters whether or not you are in first place or third place. Okay? Then the next option, or the next scenario, is selecting 3 students to attend a conference in New York. Does it matter how I say that all 3 are going? No. They're still going to New York regardless. It doesn't matter whether I say that Jalil, Christian, and then Hunter are going, or if I say Hunter, Christian, Jalil. They're still all going to New York. It doesn't matter. So that's why this is a combination. Because order does not matter for who is going. They're still going regardless. Okay? The next one says selecting a lead and an understudy for a school play. Now, if I say that Christian is the lead and then Jalil is the understudy, and then all of a sudden I switch it up, does that matter? Yes, because the lead is the person that's actually performing. Understudy is who is there in case something happens to the lead person. So this is a permutation because order matters. Okay? The next one says assigning students to their seats on the first day of school. Doesn't matter where I seat everybody on the first day. No, that is a combination. Most teachers like to put everybody in ABC order. You know that in my class, I let y'all sit where y'all want to, mostly because I want to see who to not put you next to later on when y'all start acting up. So it doesn't matter on the first day because you're probably going to move them around anyways. All right, and then selecting 3 numbers in a combination lock. Does it matter which 3 numbers I put in for my combination lock? Well, yeah, because if 1, 2, 3 is what unlocks it and I put in 3, 2, 1, is it going to unlock it? No. So this combination word tricks you up because technically it is a permutation because it matters how you put the numbers in that lock. All right. So that's the notes for day 3 for combinations. The classwork, 1 through 10 are all combinations. You don't have to choose the difference between permutation and combination. All of these are combinations. You're just reading the problem and solving for how many combinations there are for 1 through 10. That's all you're doing for day 3. Day 4 does not have a video because I just want you to practice the difference between permutations and combinations. So for tomorrow's classwork, for day 4, you're going to take these 14 questions and you're going to, on the first 4, you're just telling me, is it a permutation or combination, period. That's it. Okay? And then for 5 through 14, you're telling me, is it a permutation or a combination? And then you're going to tell me what the total is. How many permutations are available or how many combinations are available. So you have, on 5 through 14, you have to make sure to choose the right equation or the right option in your calculator. Because I got tripped up doing this too whenever I was doing the problem. So read carefully. Don't overthink it when you're doing these, okay? If you have questions, let me know. I'll gladly help you, all right? I'll see you guys later. I miss you. Bye.